So this question is from the 2024 Irish Maths Olympiad, which happened a few days ago as of recording this video, and this is the 8th question on the test. So basically what it says is that if a, b, and c are positive integers, with a less than or equal to c and b less than or equal to c, prove that this inequality is true. So I'd recommend that you give it a go yourself, because it's not that difficult as long as you know some of the basic inequalities used to prove other inequalities. But if you're still struggling with it, I'd suggest that you look at the factors of 2024, and that's what made me notice it. So I'd suggest that you pause the video and give it a go. So basically what happened is I looked at this at first and I was like, I have no idea, and I just moved on to doing some other questions. And then while I was doing those other questions, I ended up factorizing 2024 to kind of help me solve those other questions, because it was helpful to use the factors. And what I found is that 2024 is equal to, if you do the prime factorization, it's 2 cubed times 11 times 23. And basically, I had this prime factorization beside me. I didn't even have it beside me. I had this kind of in the back of my head from doing the other questions. And then I was just staring at this. And what I noticed is, well, we have 11 here. Here we have 10. We have 23 here. Here we have 22. And here we have 7. And this 2 cubed is just an 8. So each of these is one less than one of these factors. And if you notice that the coefficients before each of the a, b, and c here is 1, these coefficients actually add up to be the prime factors. This one's 11, this one's 23, and this one's 8. So what I thought is, if we can do separate inequalities for each one of these brackets, then multiply them all together, we'll end up multiplying 8 by 11 by 23, and that'll give us the 2024 that we need on this side. And of course, I think the easiest inequality to do this with is just the AMGM inequality. It's just the first one I tried. I don't know if you'd bother trying other ones, because I noticed that there's no like square terms or anything, so Cauchy-Schwarz, not really a point, and then like the harmonic mean had like weird fractions in it and stuff, so I just went with AMGM, nice and simple. So in case you're unfamiliar, the AMGM inequality states that the arithmetic mean of numbers, so you could write that as A1 plus A2 plus ... all the way up to AN, all over n. So that's just the normal way of calculating an average, so you add up all the numbers and divide by how many numbers there are. That's always going to be greater than or equal to the geometric mean of those numbers, and the geometric mean of numbers is basically just the nth root of multiplying all those numbers together. So just a1, a2, ... multiplied all with up until an. So that's the AMGM inequality, and we're going to just do that for each of the brackets. So let me just copy down the inequality down here, and we'll just work through it bracket by bracket. So if we do this one first, and another thing to notice is that we want this n, this is the only kind of constant term, I suppose, we want this to be 11 so that we can end up multiplying it together. So instead of doing the arithmetic mean of a and 10b, if you do the arithmetic mean of a plus b plus b plus b ... and you just do 10 b's, so 10 times, then we have 11 terms. So what we'll have is we'll have this divided by 11 as our left hand side, because that's the arithmetic mean of those numbers, greater than or equal to the 11th root, and then we multiply all these numbers together. So we'll have 1a and we'll have 10 b's. So a times b 10 times, which is b to the power of 10. And then just to kind of make it a bit more easy to write, so you see in our original inequality, we have the 2024 on the right hand side. So I'm just going to bring this 11 up to the other side. And what we'll get is that a plus 10b, because remember there are 10 b's there, is going to be greater than or equal to 11 times the 11th root of a times b to the power of 10. That's the first important inequality. The second one, of course, is just doing the same thing with the b and the 22c. So if we do this same kind of trick, if we do b plus c plus c plus c ... and we do 22 c's here, 22 times, I'll write it the same way. And then how many things do we have? Well, we have 23 things, because we have the b as well. So that's the arithmetic mean of all these numbers, greater than or equal to the 23rd root of b times c to the power of 22. Because we're going to have b times c, and remember there's 22 c's. And then again, I'm just going to do the trick, not the trick, I'm going to move the 23 to the other side, giving us b plus 22c greater than or equal to 23 times the 23rd root, that's kind of hard to see, 23rd root of bc to the 22. I don't know why I'm writing these square roots so big. There. So that's the second important inequality. And then the third important inequality is just with the last bracket. So we have c plus 7a. Again, we're just going to do the same trick. C plus a plus a plus a. We're going to do that 7 times, 7 a's. So that in total we have 8 terms. We have the 1c and the 7 a's. Sorry, I didn't properly plus dot dot dot, just to show that it's up to 7 times. Greater than or equal to the 7th root of c, and then how many a's do we have? Well, we have a to the power of 7, because we're multiplying 7 a's together. Then finally, we'll get that c plus, if we bring the a to the other side, 7a greater than or equal to 8 times the, sorry, this is going to be the 8th root, because we have 8 terms, so we take the 8th root. 8 times the 8th root of ca to the power of 7. Okay, so now, if we multiply these 3 inequalities together, so let me just kind of better organize this. I'll take our 3 important inequalities and put them down here. And then just take the thing that we're trying to prove, which is this. So, you can see if we multiply these 3 inequalities together, we'll get the same left-hand side as this, and then we'll get 2024 on the right-hand side by multiplying 23 by 11 by 8, and then we'll just have a bunch of messy stuff with the roots, but we won't worry about that for now. So, on the left-hand side, if we just multiply all of these inequalities together, on the left-hand side we're just going to have pretty much all of these things, so I'm not going to write that again. So, actually I will. I'll say multiply the 3 inequalities. And basically what we'll have on the right side, left side is just this, because we're multiplying all these together. This times this times this. Greater than or equal to, then we'll have, on the right hand side, we'll have 11 times 23 times 8, which is 2024. And then we'll have this big mess with the roots. Now, just to kind of make it a bit more, I suppose, easy to see and work with, I'm just going to write each of these in exponential form. So I'm just going to, I'll just show it individually for this one. So let's just have dot 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 greater than or equal to 11. And instead of the 11th root of a, that's the same as saying a to the power of 1 over 11 times b to the power of 10 over 11. So I'm going to do that same trick for all of them. So starting with the first inequality up here, so we'll have a to the 1 over 11, b to the 10 over 11, and we'll do this one next. So we can have the b to the 1 over 23 times c to the 22 over 23. And then finally, if we do it with this one up here, we'll have c to the power of 1 over 8, c to the 1 over 8, and then a, I think was the other one. Yeah, a to the 7 over 8. And then, of course, when we multiply numbers together, if they have the same base, we can add the exponents. So we'll have 2024, then a to the power of 1 over 11 plus 7/8. So I'm just going to do that on a calculator for the interest of time, but in the actual exam I had to do this by hand because they don't allow calculators. So when you add 1 over 11 and 7 over 8, you get 85 over 88 times, and then we'll do the same with the b, so we'll have 10 over 11 plus 1 over 23, and you'll get b to the power of 241 over 253. Now, I don't know if you have to actually write these like this. I think if you write them as decimals, it might be good enough and just like round it to one decimal place, but this is how I did it. And times c, and then we just add up those final 2 fractions, the 22 over 23 plus the 1 over 8. And what we get is we get 199 over 184. Now you might be thinking, oh my god, this is very messy. But remember, here's the statement we have to prove. So the only problem is we have a, b, and c, we just don't have the right powers. And basically what I noticed here is that the c, this is bigger than c to the power of 1. In fact, we could rewrite this as, let me just copy it back down. We can rewrite this as c to the power of 1 times c to the power of, that'll be, what's the difference there? 15? 15 over 184. Because when we add these two together, we'll get back to this, the 2 exponents. So basically what we have is we have this c, and we have this extra bit here. And then we're missing a tiny bit on the a and b. Here we just need an a to the power of 3 over 8, and that would make this a. Here we need a b to the power of 12 over 253, which would give us our b. And then we just need to get rid of this. So the idea is, since this is an inequality, we can basically replace the c to the power of 15 over 184. We can replace this by anything as long as it's smaller than or equal to this, because then this is still true. This whole left-hand side is bigger than the right-hand side. So if we were to make this smaller, this would still be true because the right hand side is just even smaller than it originally was. So that's exactly what we're going to do, and this is where we use the other condition at the start of the question, where we're told that A is less than or equal to B, sorry, A is less than or equal to C, and that B is less than or equal to C. Okay, so I think if we put some numbers on this, it's kind of better to look at. So if we want to turn this A to the 85 over 88 into an, if we want to turn that into an A to the power of 1, we need to multiply that by A to the 3 over 88. Similarly, for this B, we need to multiply this B by B to the power of 12 over 253, and that'll give us a B. And basically, if we replace this C with this, then we're done. But we need to make sure that we're allowed to do that. Are these two things, in fact, smaller than this? Okay. Now, since we know that A is smaller than or equal to C and B is smaller than or equal to C, we can kind of do some things with the exponents here. So what we can notice here is that if we add these two powers together just to see what the overall power is, I know they're not the same base or anything, but what we notice is that if we add these two exponents together, what we actually get is 15 over 184, which is the exact same as what we have for the power of C. Now, since this 15 over 84 is overall going to be to this question mark power, and we have C to the power of 15 over 184, and since this question mark is going to be smaller than C, because remember, this question mark, we have an A and a B as the bases, so an A and B are both smaller than or equal to C. So that means that this thing on the left side is always going to be smaller than or equal to the right hand side, because they're the exact same, except here the base is smaller, because A times B is always going to be at the biggest, it's going to be the same as C, or it could be smaller than C. So that means we can actually replace this C to the 15 over 184 with this, because we know that this is always going to be smaller than the C to the 15 over 184. So that's exactly what we're going to do. I'll just copy this down. Whoops. So I just copy this down, and instead of writing this C to the 15 over 184, I'm going to replace that with this, with the A to the 3 over 88 and the B to the 12 over 253. And now what we get finally is that if we write out all of this, and then remember we add the exponents A to this plus this, that'll give us A to the power of 1, B times B to the power of this times this, well, you add the powers and you get B to the power of 1, and then we just have the C to the power of 1, and we have proven that the inequality is true. And that's how I did it in the exam, except I think I did some decimal approximations, I might have messed something up, but the method's overall the same. And yeah, that's it.